2, 1, drop it.
Lithium, sodium, potassium are alkali metals in group 1. This means they have one electron in the outer s shell. This allows them to react in a similar way. The reactivity increases going down the group as the atomic radius of the atom increases, meaning the electron in the outer shell is further away from the nucleus. As the atomic radius increases, the first ionization energy decreases. The first ionization energy is the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms to form 1 mole of gaseous 1+ ions. The melting and boiling points decrease going down the group as the distance between the nucleus and the outer electrons increase. This is also the same for electronegativity. Lithium, sodium, and potassium are stored in oil. Here we see sodium. The reason it is black is because the outside layer of sodium has oxidized. If we were to cut it open, we would see that it's shiny in the middle. Lithium reacts with water to form lithium hydroxide plus hydrogen. Here we see lithium reacting with water. The lithium is floating because when lithium reacts with water, hydrogen is formed. This helps to float the lithium. The same thing is happening here for the sodium. As we see, the sodium is floating as it is reacting with the water. Sodium reacts with water to form sodium hydroxide plus hydrogen. Potassium reacting with the water is much more reactive as the potassium catches fire as soon as it hits the water. Potassium reacts with water to form potassium hydroxide plus hydrogen. If we add indicator to the water, we see it go blue.
Cause he ain't got nobody to listen. I'm blue, I've been deed, I've been died, 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 I've been deed, I've been died.
This means there was a metal hydroxide formed.
Magnesium and calcium are alkali earth metals present in group 2, meaning they have 2 electrons in the outer s shell. The atomic radius of the atom increases going down the group, meaning the electrons in the outer shell are further away from the nucleus.
NANI?貴様の拳などかほどにも効かんわい。お前はもう死んでいる。NANI?
This means that the first ionization energy decreases going down the group. The melting and boiling points also decrease going down the group as the distance between the nucleus and the outer electrons increase. The magnesium here will not react with the water as it is not in a gaseous state. Magnesium will react with water that is in a gaseous state. Magnesium plus steam reacts to form magnesium hydroxide plus hydrogen. To test if hydrogen is formed, we can use a lit splint, and if you can hear a squeaky pop, then it is hydrogen. Calcium will react with water without being heated. Calcium plus water reacts to form calcium hydroxide plus hydrogen. Again, we can do the same test as before to determine if what was formed was hydrogen. Magnesium, if heated, will react with oxygen to form magnesium oxide, which will glow bright white.
Across period 3, the atomic radius decreases. This is as the number of protons increases, so there is more attraction between the nucleus and the outer electrons. The reactivity across the period also decreases as higher temperatures are needed for a successful reaction with water or oxygen. Phosphorus, sulfur, and argon do not directly react with water. The boiling and melting points increase across the period but drop at phosphorus and argon. The first ionization energies also follow the same trend.
Aluminium is in group 3, meaning it has 3 electrons in the outer shell, 1 electron in the outer p shell. If powdered aluminium is lit on fire, it will burn with a white flame. Aluminium plus oxygen reacts to form aluminium trioxide.
Silicon reacts with oxygen at high temperatures to form silicon dioxide, which is known as glass.
Phosphorus is commonly used in matches as it is extremely reactive. Phosphorus plus oxygen reacts to form phosphorus peroxide.
Sulfur burns in oxygen with a glowing blue flame. Sulfur reacts with oxygen to form sulfur dioxide.
Chlorine bleaches litmus paper.
This means it removes all the colour from the litmus paper and bleaches it white. Argon is an inert gas, therefore it does not react with oxygen. As you see in this video, glass beaker filled with argon. Argon is more dense than the air around it, therefore it sinks and puts the handle out.
Congratulations! 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 Quack, quack. Congratulations! 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 Congratulations!